Students, in our last recordings, I have explained you finding derivative using first principle. Now, you have already, it seems that you have already done various formulae with you, and now we move ahead with the differentiation of very important function called composite function. Now, the word composite function means what? Therefore, it's a first question here, what is composite function? So, simple definition is function of a function is called composite function. Now, what do you mean by that? You shall explain using simple example. Have a look. Everybody understands f of x equal to x square is a function. G of x equal to sine of x is another function. If you club them together, such as, you see, sine of x square. So what exactly have I done? Sine was here, x square was here. So is it not sine of x square does mean sine of x square does mean you have gone for g of x square. But what was x square? X square was f of x. So g of f of x is nothing but sine of x square. But it could have been different, such as f of g of x. This can also be called composite function. What exactly you mean by this? See, I know what is g of x, sine x. What is f of x, x square. So when x comes here, it is going to be x square. So when g of x comes here, it is going to be g of x, the whole square. But what is g of x? It is sine x, and therefore this function is nothing but sine square x. So sine of x square is not sine square x, does mean g of f of x is not f of g of x. These are two different concepts, but function of a function is called composite function. Now this can be explained using certain examples. Number one example for this is simple example. Say y equal to log of e raised to x. You know, log is function, e raised to x is a function. So log of e raised to x is composite function. Another example, y equal to root of tan of x. You understand? Is root a function? Yes. Is tan x a function? Yes. So root of tan x is another function called composite function. So friends, we have a formula to differentiate composite function, and this is what the formula. If y is a differentiable function of u and u is a differential function of x. What does it mean? When x changes, u changes, and when u changes, y has to change. So y depends on u and u depends on x. So in short, when you are differentiating y with respect to x, you got to differentiate y with respect to u first and then u with respect to x first. So this becomes a chain, and therefore this is also called chain rule. So derivative of a composite function is nothing but finding derivative of each and every functions involved in it. Okay? Yes. Now, we will try to learn how to differentiate given problem y equal to sine of x square, which falls under category called composite function. However, when you differentiate, you understand sine itself is a function, x square is another function. So this becomes composite function. So what to do? Let u equal to x square. U equal to x square, when you say, therefore y becomes sine of u. Y becomes sine of u. Now dy by du becomes derivative of sine is cos of u. You understand? But what was u? U was x square, and therefore it becomes cos of x square. Is that? Yes. Now u is a function of x square. You can differentiate u with respect to x, such as du by dx is equal to 2x. Now applying the formula, that is dy by dx equal to dy by du into du by dx. Everybody knows this. Now, what is dy by du? It is already written. It is cos of x square. And what is du by dx? It is 2x. That's the answer. So in short, when you want to differentiate sine of x square, you see sine derivative is cos. Let x square be written as it is, but don't forget to differentiate that x square whose derivative is 2x. These two together give the final answer. Yes, friends. Now this is the second problem. Y equal to log of tan of e raised to x. You can see from the problem itself, there are a couple of functions involved. One is e raised to x, the other one is tan, then the log. So when you differentiate, try to differentiate this function, you got to differentiate all the functions present here. So the simple method to differentiate is write dy by dx. You see, you should put hand here as if it is x. So when it is log of x, what is its derivative? 1 upon x. Derivative of log x is 1 upon x. So as if it is x, you should write tan of e raised to x. But it was not x, and therefore you got to multiply by derivative of that inner function, which is tan of e raised to x. Now the next step is 1 upon tan of e raised to x multiplied by, you see, again you put hand, tan of x. What is its derivative? Sec square x. So it is going to be sec square, but what is that? It is not x, it is e raised to x. And therefore, you got to multiply by derivative of that inner function as well. Now, the last step is you write sec square e raised to x upon tan of e raised to x, and now multiplied by derivative of e raised to x. What is that? E raised to x, and this is your final answer. So, when you have a composite function, you should differentiate each and every functions involved in this problem. Hope you understood. You can practice many more composite function problem generated by your own. If you have any difficulty, please feel free to ask me. I will mention my mobile number, email address in the link below. Please feel free to call me. Thank you.